This section is over rational expressions, and hopefully the first thing that's running through your mind is, what is rational expressions? Well, if you look at the prefix here, ratio, that actually tells you exactly what we're going to be going over. Ratio is just a fancy word for fractions, so what we're going to be doing in this set of videos is working with fractions. But not just basic elementary school type of fractions that we saw in the very first set of videos, but here rational expressions are a more difficult type of fractions, and I have 3 examples listed here. Now, they can be as simple as your elementary school fractions, but most likely they're going to be more complicated, like examples 2 and 3. Rational expressions are fractions in which we have polynomials involved. Notice we have a polynomial in the numerator and we have a polynomial in the denominator. And this makes sense that we're doing this section of videos next because we just talked about polynomials and factoring in the last 2 sections. So let's move on to typical operations. The first one is simplifying. All we want to do is simplify these rational expressions. Now I'm going to tell you here what you can do and what you cannot do, and I point both of these out because I see what we cannot do as a typical mistake that students make all the time. So hopefully if I point it out now, this is a mistake that you will not make from here on out. You cannot simplify fractions or rational expressions by canceling between a numerator and denominator when you are trying to add or subtract. So if I were trying to simplify this top example here, I would have to note that I had pretend parentheses around both my numerator and denominator. And that's something we've discussed many times, so that should be nothing new at this time. On the top, we have 2 plus 5, which gives us 7. On the bottom, 3 minus 5 gives me negative 2. So the only way that I can simplify this example is by adding and subtracting. Now, I want to point out that you cannot simplify this example by canceling out. Notice that I see 5s in both my numerator and my denominator, but that does not mean I can cancel out these 5s. Because if I did it in that fashion, that means I would get the answer of 2/3. And I should know that that is not okay because 2/3 is definitely not the same thing as negative 7/2. So you cannot cancel when you are adding or subtracting. But if I look down here, I can cancel between numerator and denominator when I am multiplying. So here I have 2 times 5 and 3 times 5. So I'm multiplying here, so I can cancel my 5s in this fashion, and that gives me my ultimate answer of 2/3. Now I could also multiply these, but that's just going to make my problem more complicated. So when you're simplifying fractions or rational expressions, what you want to do is you want to cancel, but you can only cancel when you are multiplying, not adding, subtracting, dividing, or any other operation. So let's go ahead and see some examples of these here. I have 2 of them. The first one, x squared minus 16 all over x squared minus x minus 12. And this is a perfect example of a rational expression. This is what most of your problems will look like. So what I want to do here is I want to simplify this. But note at this time I cannot cancel anything. My operations that I see here are subtraction. So if your first instinct was to come in and cancel out these x squareds, then that would be incorrect. Or if you wanted to reduce my 16 over 12, you cannot do that. So at this time, I cannot cancel anything from my rational expression here. Well, what I need to do is I need to put it in multiplied form because I can cancel when I'm multiplying. And the way that we put this into multiplying form is using your new best friend in math, which is factoring. So what you need to do is you need to factor the numerator, factor the denominator. That puts it into multiplication form, and then you can cancel any identical factors. So basically, you have to review your whole factoring checklist. Let's focus on the numerator first. If I go through my checklist, it is in descending order, so that's good. I do not have any common factors. I have two terms, which are both squares, and this is a subtraction, so this is a difference of squares. So I'm going to set up my two sets of parentheses. X times x gives me x squared, 4 times 4 gives me 16, and these factor into opposite signs, one positive, one negative, because difference of squares always factors into conjugates. Now my numerator is factored completely, so let us switch our focus to the denominator. Again, running through my checklist, it's in descending order. I have no common factors. I have 3 terms, so I get to factor this as a trinomial, which is the same thing as unfoiling it, or reverse foiling. X times x gives me x squared. Factors of 12, I have lots of choices. 1 times 12, 2 times 6, or 3 times 4. I like to start with the ones that are closest together. Not to mention, I know in this example, those add or subtract to give me my middle term here of 1. So I'm going to use 4 and 3. So my outside is a 3x, my inside is a 4x. To give me a negative x, I need my 4 to be negative and my 3 to be positive. So negative 4 plus 3. Now my bottom is factored completely. So notice that you've taken things from addition and subtraction format into multiplication format. So that's what factoring does for us. So now we can cancel out any like factors. And this x minus 4 matches exactly with this x minus 4. So those cancel completely. That leaves me with an x plus 4 in the numerator and an x plus 3 in the denominator. Now you want to make sure that you cannot cancel any farther. And again, your first instinct might be to cancel out these x's here. But note, you cannot do that because this is addition and subtraction form. So I cannot cancel when I'm adding or subtracting. So this is the farthest that I can simplify this. So this here is my final answer. So I suggest that you try and simplify the irrational expression in example 2 on your own. Okay, so our steps are the same. I cannot cancel anything yet because it's addition and subtraction format, so let me go ahead and factor this. Now, if I look at the numerator, I do notice that I have a common factor, but I also notice that it's not in the typical order that I like it to be in. So let me go ahead and rearrange this and put this in descending order. The negative switches with the 2x, and then my positive 14 becomes at the end of my polynomial. And I'm just going to copy down my numerator as is. I'm going to try and keep things consistent here. Now let me try and factor this. Back to my numerator, I do notice it has a common factor of 2, but also notice I have a negative in the front, so it's probably going to be best to factor out a negative 2. If I do that, that leaves me with a positive x and a minus 7. And you're always more than welcome to double check that by distributing or multiplying it back out and make sure that we get the same answer. Now I cannot factor that any farther, so let me switch my focus to the denominator. I have again a common factor of x, so if I take that out, that leaves me with x minus 7. And I cannot factor my denominator any farther. I have switched it from subtraction format into multiplication format. Since these are multiplied, that means I can cancel identical factors, so I can cancel these x minus 7s, and that leaves me with just a negative 2 divided by x. So there is my final answer. So in this video, we've talked about how to simplify rational expressions. And basically, it's just two steps. Factor both the numerator and the denominator, and then cancel any identical factors.